Hello, today I would like to present section A for the assignment computer architecture, which is Raspberry Pi installation simulator setup. Firstly, we need to download the visualization software VirtualBox from the website, and then we need to install to our computer. After that, we need to download the Raspbian OS image from the website. The total size for the file is around 1.36 GB. And now we want to load the Raspbian virtual image in VirtualBox by click the new button, and then we rename or name the file with pixel. Here is the machine folder where the file is located. Type is Microsoft Windows because I'm using Windows right now. And memory size we change to 1024. Hard disk, just select virtual hard disk now, and then we create. Okay, this is for the file location. And file size we change to 20 GB. Hard disk file type we just select with the VirtualBox this image, and storage on physical hard disk in dynamically allocated. Now we create. Okay, choose pixel and start. Starting the pixel VirtualBox. This will take some moment. Okay, now we will select the startup disk. We select the previous downloaded file, which is pixel.iso, and then we choose start. Okay, now the VirtualBox version 6.1 is booting. This will take some moment too. Okay, the pixel is still running. Now this is the interface for the simulator. We want to set up GPIO emulator by pressing the terminal icon, and then we will write the terminal by typing wget http open.iec.uned.es/iot for SMEs /again IoT for SMEs .zip. Enter. The HTTP request is sent, and now we want to unzip the zipped file with writing or typing the unzip IoT for SME .zip. Enter. Okay, now the environment for Raspberry Pi is ready to use. That's all for session A. Now I would like to present for the session B assignment, which is booting Raspberry Pi for hardware. This is our Raspberry Pi 3, and then this is the USB cable to connect with the power supply, and then this is the HDMI cable connected with the monitor. Two peripherals, which is one for keyboard and another one is for mouse. Now we want to boot the Raspberry Pi. Raspberry Pi 3 is booting. The keyboard is also well functioned. Also the mouse. Okay, so here is the interface. Let's try for the terminal. Command if config enter. All is connected and run. Thank you.
My name is Muhammad Zainal Karib. So my turn is to explain about the section C, which is watching Raspberry Pi virtual memory. So for this part, I will use the same command for the section from the section A. Okay, as you can see here in the LTX, which is the black box. I already insert the command for the wget http open.iec here to open which is to get the environment for the Raspberry Pi. So and then I proceed to unzip the IoT for SMAS. Okay, next I will go to part virtual memory for Raspberry Pi. So the command start with vm start. So this command is actually stand for virtual memory statistic. As you can see, the vm start utility summarize the current state of the Raspberry Pi virtual memory system and update it, or it set a number of time or a set time interval. So the vm start utility is command line, so it must be executed from a terminal window, such as the one that is displayed by the LX terminal. The LX terminal basically the black box that display in the Oracle VM VirtualBox. Okay, then after I insert the command the vm start, as you can see here, it show the some variable which are the R, B, SWPD, free, buff, catch, SI, SOBI, and others. So as we can see, the R is indicated for the number of process currently waiting to run. B is the number of the process currently to asleep, and yes, the free is basically for the free space for the memory, and the buff also for the cache. Okay, so the next instruction for section C is to state the interval and the count for the memory to read. So we start to insert the interval that we need. For instance, the interval is 5 and the count is 10. So it will basically display about 10 data, because the command that we put in here is for the 5-second delay and 10 number of memory. So basically it will display about 10 data. So it will begin from R and B. So it repeat about 10 data starting from 00, because we doesn't open any software or any apps, so it will not run any data from the memory. Okay, there are 10 data. 1 2 3 4 5 6 7 8 9 10. Okay, and then the next instruction, uh, 5 and 10. So the next instruction is to open any, we run the simulation, but at the same time we close the window and run any software such as a Google website, or any software that available. So we run first, and then we open any browser. We can type anything that we want. Okay, let's see what happened to the data. So after running the Google browser, we can see that from the second to the 10 data, the browser is being run. So about the second data, it shows that the R is waiting to run this first instruction. So on that time, the free memory is about 564040. And after the browser is fully run, the unallocated memory is reduced to 72772. So also for the cache, it increased from 29269512 to 310164. So from this, the browser data is being read and it's stored to the memory. So from the first read for BI, it has a value of 0. It has the value of 4108 here, because of the VM start command that we insert in the black box command. So for the software, for the browser that we run earlier, the BI will be read from the second data, to the next, which is for the third data. So we can see the BI increase from 4108 to 10151, because the instruction for open the browser is just read but not write. So the free buff and the cache value is changing from the second to the 10 data, because during that time it still has the other instruction that being read and write at the memory. So from the BI and the BO, the value is near to 0 because of the browser in idle, so there is no read or write condition in that situation. So you can see that from the six data, it start to begin to come 0 at that point. Okay, that's all for the section C.
Section D. For section D is about programming GPIO hardware only, which we can find the version of Python install and type at the terminal Python, and will out for version Python 2, or we can type Python 3 and it will show the Python 3 version. Then we can update the Raspbian by using the shown coding. Type it at the terminal. type sudo apt-get update and sudo apt/get upgrade. And we install the newest package and upgrade it automatically. Then we can also install Python GPIO library if first time using the GPIO. Just type it at the terminal and it will automatically install it for us. Then by using Python, we can use the command below, import RPA, and we can set the GPIO pin. For example, this one, GPIO .set mode, set pin 12 as the out pin, and type in the coding at the Python 3. Save the coding first, run, and type the coding GPIO read all to read the terminal to read the pin out of the Raspberry Pi. GPIO/read all, and then we can see at pin 12 it's set as output as the mode, and we can change it out, we can change it to in, and we will see the difference. Type it again, GPIO read all, and then we can see that pin 12 has been changed from out mode into in mode. For session E, building a simple circuit by using Python 3 IDLE, and use this following code and run the coding on the Python 3 at the Raspberry simulator. First, so open the Python 3 and then click file and open new file, and we can write down our new code. And run the module, save it, create a file at the desktop using whatever name that's suitable for your project or coding, and save. And if no error, mean it's good. And then I need to re-update the coding because last coding did not working well, did not show the output that we need, so I changed the coding a little bit. So here we can see the GPIO emulator, so that we can know the use the coding are working out. For first, if you can see the if GPIO input 23 is false, means 0, for output 4 and 17 will turn into 1, and then input 15, if this were true, equal to 1, 18 and 19, 21 will become high or 1, and input 26 if vice versa, for output 4 and 17 it will change them to low. Also the same with input 24, it will change 18 and 21 pin to low. And that's all.
Okay, the section F, to turn Wi-Fi on the Raspberry Pi. So the first you need to simply open a terminal window and execute this command. Okay, sudo apt underscore get install WPA GUI, and then you enter, it will run smoothly. And then the second command, you just insert the WPA underscore GUI. After that, it will pop up the WPA guide window, and then you need to scan first. After you click the scan button, the supplicant scan for available APS and display a list in a new window. After that, you choose the mat hijau and enter the PSK, which is the password that we set for the Wi-Fi, and then choose the updater. You will see the current status. That's all.